Good morning, everyone. My name is Douglas McKee. I'll be going over IPv6 implementation through a business called Comcast and how they use that throughout their company. The points of discussion that we're going to go over are the basic understandings and history of IPv6. We're going to review Comcast implementation of IPv6. We're going to review and describe the thought process that went behind the decision. We're going to identify stakeholders that had input on this process, and we're going to determine if you feel the technology implementation was good or bad based on that decision why, and we're going to support some of those conclusions. Going into the history of IPv6, in 1992, the Internet Engineering Task Force, or IETF, recognized the IPv4 address scheme was being used up quicker than expected. This is due to a lot of devices having IPs that were not initially thought of, due to mobile devices, tablets, cell phones, other things that were not created at that specific time. They needed to come up with a new plan to solve this issue. So the answer to that was IPv6, which was the move from a 32-bit address scheme to a 128-bit address system that was hexadecimal notation. This is a large enough amount of addresses that will never run out. There are 340 undecillion addresses, and about 42 undecillion addresses are currently defined and usable. This is mainly due to certain portion of the address space being used for public addressing. And just to give you an idea of how big undecillion is, this is mainly something that would have 36 zeros on the end of that. So it's a very large number, and we are never going to run out of addressing. At least that's initially what is thought. So here's a little comparison table from IPv4 up to IPv6. The first size or column would compare the address size, which is 32-bit over to 128, from what we already discussed. The address format, which is in dotted decimal notation for IPv4, depending on what class address you are in, and IPv6, which is in hexadecimal notation with separators of colons. The prefix notation will obviously be a slash notation, whether it's a slash 8 for A, 16 for B, 24 for C, and so on and so forth. IPv6 will could be anything up to a slash 48 or a slash 64. And the bottom column is the number of addresses. For IPv4, obviously these are already exhausted, but it was all the way up to 4,294,967,296. Now IPv6 is basically 2 to the 128th power, or the 340 undecillion. Here's a little just how-to for hexadecimal notation, just to give you an idea of how it works in binary, hexadecimal, and decimal. Basically everything from 0 all the way up to 9 is going to be numeral, and everything from 10 all the way up to 15 is going to be alphanumerical. So 10 would be alpha, 11 would be bravo, so on and so forth, all the way up to foxtrot, which would be 15. And binaries listed off to the side. Now the main problem with IPv4 was that they were running out of IP space, and this is where NAT would come into play, otherwise known as network address translation. It makes up your network slower and gets rid of end-to-end addressing because there's a lot of translation going on between that, NAT, and PAT. IP version 6 solves all of these issues. The main pro to IPv6 is the amount of address space that we gain from this. Obviously, you can see the difference between the numbers between IP version 4 and IP version 6. It brings back end-to-end addressing and takes out NAT. This in turn makes the network faster, less latency since there is no translation going on through the routing process. It is also very secure and reduces bandwidth due to there being no IP level checksum. Some of the cons to IPv6 are the training that these companies would have to go into, administrators on IPv6. Obviously, people are going to have to go through training, schooling, in order to implement this at their company level. And the companies are out to push this migration since it's something new. A lot of administrators are going to want to stick to what they know. So if they don't know it, then they're going to stick with IPv4 until they're forced to. Also, equipment costs and compatibility issues with certain things that do not have IPv6. Obviously, they're going to have to raise equipment costs and replace some things if they want to make that migration. And lastly, there's privacy issues. People are being concerned about having public IPs instead of a private address scheme. The provider can do some things listed below that he would not normally be able to do, such as throttling bandwidth and banning users, tracking the individual personally, giving information to big businesses for lawsuits, giving information to the police and for criminal actions, giving information to the government, and using someone else's connection to get them sued or arrested in this case. But more or less, there's more pros than cons. A little about Comcast, the company. It's a global media technology company with two primary businesses, Comcast Cable and NBC Universal. Comcast Cable is one of the nation's largest video high-speed internet and phone providers to residential customers under the Xfinity brand, which is mainly providing internet services and other providers to these services businesses. NBC Universal operates news, entertainment, and sports cable networks, NBC and Telemundo broadcast networks, television production operation, television station groups, Universal Pictures, and Universal Parks and Resorts. Now, the business case implementation. This is where their IPv addressing was nearly implemented a decade ago, so they were on the frontier of actually this technology. There was no specific case or business case that I could actually find over the internet, but there are plenty of sources and documentations out there at their business and customer levels and how they actually did this. As stated by John Brozakowski, we are well on the way to enabling all of our internet properties with IPv6. In the last year, we became the first major US ISP to deploy dual stack connectivity that would both support IPv4 and IPv6 connections throughout 100% of our network. IPv6 implementation to date. Some of the things listed below are some of the things that Comcast has done, and this is also referenced by John Brozakowski. So today we have tens of millions of cable modems being managed by IPv6 only. Less than 5% of cable modems across Comcast networks rely on IPv4 today. Over 70% and growing Comcast broadband customers, residential and commercial, are actively provisioned with IPv6 support today. Well over 15% of Comcast Internet's traffic is over IPv6. The most popular Comcast Internet properties are currently enabled with dual stack support. All of Comcast's products and services have plans or have already begun preparation to support IPv6 only. Comcast's next generation entertainment operating system, X1, is migrating to IPv6. So, why did they need to go through this process, and what was the thought decision behind it? So obviously they recognized that the issue took initiative, and they wanted to move forward, right, with this new technology ahead of their companies behind, to the side of them. They want to be the best possible service towards their customers and their business partners. So they just wanted to sit at the top. Now, some of the stakeholders that were involved were obviously going to be Comcast, Xfinity, all the business partners that would be investing in them, their stockholders investing in the company, and consumers that would be using these services, whether it be their internet, phone, or uh, their TV services. So, was this good or a bad decision for the company? I believe it's a very good decision for the company. Uh, they were at the forefront of their implementation. So when this came out in 1994, saying that, hey, we need to take initiative and go and develop another technology, and a decade behind that of where we are at today, which would basically be about 2006. So a decade after this is came up with, Comcast makes the move to push forward this technology onto their network. So they're also the first to use the dual stack technology over their whole network, for others to follow. So I would say they committed to a standard for others to follow behind them. Would I recommend this strategy to another company? I definitely would recommend this to other companies out there. So from what I could read, there was no bad things that came about from their implementation. I saw no issues with what they came about and how they implemented their dual stack technology over their entire network. And it's great since IPv4 and IPv6 addresses can talk to each other, depending on your compatibility issues with your neighbors, and everything it can communicate. So, in conclusion, Aaron states that now Aaron has reached IPv4 exhaustion. We strongly encourage that you adopt IPv6 to your networks. Not only does IPv6 offer a variety of improvements over IPv4, but the internet simply cannot continue without it. So they're basically saying that, hey, we are your provider. We are giving you these IP addresses. It's one of the regional collectors of IPs. So they're saying we're not going to give out IPv4 addresses anymore, and we're forcing you essentially to make that migration. So Comcast is making a wave into the future, and something about saying that it worked. So obviously the dual stack technology would suffice for that. Also, here are my references. I went about and got various vendors and descriptions off the internet, whether it be a basic technology for IPv6 or overviews, or just articles in general that I thought would be helpful in the matter, in order to explain my scenario. So with that, this concludes my presentation. I hope you like it. If you have any questions, please post it in the discussion forums. I know that I am approximately 5 minutes short here, and I'm tracking that already, so I will take a hit on that. So thank you very much for your time, and I appreciate it.